Hello everybody and welcome to this new review by the 3D printing market. In today's review we're going to test this the Dimafix. This is an adhesive for 3D printers, especially for this type of 3D printers, the FFF or FDM 3D printer. This adhesive will help us keep the first layer strongly bonded to the build plate. This is a glass build plate. This adhesive will help us keep the first layer strongly bonded to the build plate surface. It will also help to prevent the warping, especially when we are working with ABS. But the key feature about this adhesive is it is temperature responsive, meaning we get a strong adherence at a high temperatures. But this will also allow us to easily remove the object from the build plate when the temperature is let's say lower, below 50 degrees. The object on this build plate will easily be removed from here. So that's a great feature. That's a great feature for an adhesive especially made for this type of 3D printers. So we're going to take a look to the company's website to see the characteristics about this adhesive a bit more in depth. So let's take a look to the website and we'll go on with our test. We can find some more info at the company's website, www.dima3d.com, and we can see here at the right side of the screen the Dimafix. So let's click on it. Okay, according to this info, the key features are it provides great grip between plastic and glass, so warping is not a problem even in large ABS parts. You will be able to print in all kind of thermoplastic materials. The adhesion property will be activated when the heated bed's temperature is higher than 50 degrees. This is one of the key features we mentioned before. While the bed is hot, the adhesive effect will be working even in large prints. When the heated bed's temperature goes down to 40 or 50 degrees, the adhesion effect disappears and the model will be easily detached. This is another key feature we mentioned before. Well, we can clean it just with water. Every bottle of 400 milliliters will last for about 100 uses. Now let's check the product specific website, which we can find here. Let's click on this link. Well, this is the product's website, where we can see here the same graphic or very similar graphic. We click here in features, we see almost the same we saw before. Let's click here. These are the instruction. We have to apply, wait for a few seconds and start printing. It has no special instructions. Here we can find this graphic. This is a more user-friendly graphic where we can find there are 4 regions. The first one is below 60 degrees, which is called the zone of self-detach with very weak adherence. The second region between 65 to 75 degrees is the average adherence zone for simple geometries, and the third one between 75 degrees to 95 is the high adherence area for complex geometries and long-lasting prints. And finally, the fourth, above 95 degrees, is called the very high adherence zone for very complex geometries, very large pieces and very long-lasting prints. According to this rollover on the upper side of the screen, all we have to do is spray the surface on the area we plan to print, wait for a few seconds to dry, and we can start to print, and that's what we're going to do next. But before, let me note there is also a technical paper available on the website. It's here, let's click on it. It's a PDF file with more in-depth technical specifications. You can find the same graphics we saw before. Here the same for regions, for the different use cases. Here they are a bit more explained. Some more graphics. Even more, there is also a series of technical analysis, very interesting and worth reading, so we highly recommend you to take a look to it. Okay, so now we have checked the company's website to see how it works and how should we use it. So we're going to follow the instructions. So we have to shake the bottle and then spray over the build plate, over this surface. So let's go ahead. Well, that's enough. We have to wait some seconds to get it dry, and then we'll use it here on the 3D printer. Well, these are the results of our tests. We performed 4 tests. This one was at 60 degrees and it was completely impossible to make the 3D print, as the first layer got detached from the build plate. So well, this temperature is not really to keep the ABS bonded to the surface. This is just a temperature where we can detach the object. We did another test at 70 degrees. The 3D printing process went okay, was performing okay, but a few minutes later the first layer became too detached from the build plate. So this 3D print failed at 70 degrees. Another one we did at 80 degrees went okay, but we had to stop the 3D printing process because we had an issue. But we kept the plate temperature at 80 degrees. It continued to get bonded to the surface, so the object didn't get detached. And finally we made another one, a completely object at 85 degrees. This time the 3D print went completely okay. The object got strongly bonded to the surface during the complete 3D printing process. So at 85 degrees the octopus got attached to the surface. We have no warping at all. You can see the tentacles, which are very thin, and they are very suitable to be to the warping. To remove the object from the build plate, we just had to wait for the temperature to be below 60 degrees, and we could easily detach it from the build plate just by slightly pulling from it, as you can see. Well, after the tests, we can say the Dimafix worked exactly as expected. We had a very good 3D print at 85 degrees, another very good 3D print at 80 degrees. At 70 degrees we had a not so good 3D print, and below 60 degrees it was impossible and the object could be easily detached from the build plate. So that's all we can say. Thank you very much. We hope this review you find it useful, and we'll see in the next review. Goodbye.